So now we're on number 7. We have the same graph we had in number 5 below, and now we're looking at drawing a secant line between when x is 1 and when x is 5. So I've lined up my ruler already, and let's go ahead and draw in a line that is tangent. That's not it. So we have a tangent line drawn in, and show that there's a point where the derivative, which would be the slope of the tangent line, is equal to the secant. So now I'm going to move my ruler, see if I can make it tangent, and I can make it tangent right about there. So go ahead and draw that line in. And there we have our tangent line. And is h differentiable from 1 to 5? So let's move my ruler out of the way. From 1 to 5, are we differentiable? And we are, and I've covered it up, but initially right here, that was a closed circle, which means it was included in the domain of 1 to 5, that point would be included. So there's no discontinuity here, nothing's going on. This is differentiable from 1 to 5. So why is it continuous from 1 to 5? Well, we have an open circle down here, which means that's not included in the domain from 1 to 5. So the only part of my graph that I'm worried about from 1 to 5 is what I've just highlighted in red. So there's a step discontinuity at 5. However, the step discontinuity is after 5. So when x is greater than 5. So moving on to number 8. This is what we need to know. And when I say what we need to know, this is what you need to memorize. Now, this is a lot like our other theorem that we had, which was the intermediate value theorem. We need to show each of these things. So first thing, we have to show that f is differentiable from a to b. Second thing we need to show, f is continuous from a to b. If those things are true, then we know this has to be true, which means the derivative at c, or the tangent line at x equals c, that slope has to be equal to the slope of the secant line. So that f of b minus f of a over b minus a, all that is the slope of the secant line. So this is just the secant line slope. That's all it is. So let's go ahead and identify where we had our hypothesis true and our conclusion true. If you go back and look and figure out which ones are true, can you go ahead and do that now? I'd like you to go ahead and pause the video and fill in this, and this right now. So go ahead and pause your video, please. So I have that the hypothesis is true and the conclusion is true for 1, 2, 4, and 7. So that means in all of those, 1, 2, 4, and 7, f was differentiable on the domain we are given. F was also continuous on the domain we are given, and we found a tangent line that was parallel to the secant line within the domain we were given. The next bullet says the hypotheses and the conclusions were not true. That happened in 3 and in 5. So what happened is we didn't meet the hypothesis, which meant we also did not have a tangent line parallel to the secant line. In the last bullet, it says the conclusion was true, but the hypothesis wasn't. So at number 6, we could draw the secant line, and we actually could find a tangent line parallel to that secant line. However, our hypothesis was not true because our function wasn't continuous over the interval. We had this big jump discontinuity, and it was not differentiable over the interval. As you notice, I've crossed out number 9, and I just want to talk about what this actually means. In basic terms, what does this mean? The mean value theorem down here. It means the derivative at x is c is equal to the slope from a to b. and that's the slope of the secant line, so just a regular plain old slope. And that is your mean value theorem. And again, you do need to memorize the mean value theorem and be able to use it and apply it. Have a nice evening.